Hello students, so this is the motion chapter part 5 where I am going to discuss about the topic acceleration. So distance, displacement, speed, velocity we have already discussed in the previous fourth parts, and the fact is that a lot of numericals also I have solved there. Okay, so now today's topic is on acceleration basically. So acceleration is generally denoted by A. Okay, it is denoted by A. So what is acceleration? Acceleration, you might have heard a term that is accelerator, right? In bike or scooter, its name is accelerator. What accelerators do actually? It increase or decrease the speed of bike, right? On that concept actually means on the basic concept of acceleration, that instrument is known as accelerator. How? So acceleration means we can increase or decrease the speed, right? So when acceleration is happening, that means it has some increment, means change in velocity. Okay, so acceleration is producing means some change of velocity is happening, some change of velocity, and since time is going on, so with respect to time it is happening. Okay, so change of velocity with respect to time is known as acceleration, or even further more simple definition of it is rate of change of velocity. Rate of change of velocity is also known as acceleration. Okay, now change of velocity means what? There are two types of velocities, I think. So which one are those? Like initial velocity and final velocity, right? So final velocity, if you know that final velocity is denoted by V, and initial velocity is denoted by U, right? If you don't know, just remember that initial velocity is denoted by U and final velocity is denoted by V. So change in velocity means what? That is final velocity minus initial velocity, V minus U, by time, so it is T. And acceleration is denoted by A, so finally our formula is coming, that is V minus U by T. You need to remember this formula, very simple, no such kind of difficulties are there. Now if you furthermore simplify this term, you will get AT equals to V minus U after cross multiplying this at this side, and finally you will get V equals to U plus AT. So this is the formula. This formula is also known as equation of motion. Okay, this formula is also known as kinematics equation or first equation of motion. First equation of motion. So a lot of formulas are there. I am going to show all the formulas in the next class graphically, where graphical representation will be discussed. But before that, just we need to know something like what is the unit of acceleration and what kind of acceleration is possible. Okay, so basically you can imagine, or you can means just think about the concept of acceleration, that from distance we were getting speed, means speed equals to distance by time. Similarly, velocity equals to displacement by time. In the previous class we have discussed about those. Now what is acceleration? What we are getting? It is velocity by time. So acceleration is related to velocity. If acceleration is related to velocity, then for velocity is having the vector quantities in the form of vector quantity. Velocity is which kind of quantity? Vector quantity. So acceleration will also be vector quantity, right? Since displacement was vector quantity, this is why velocity is vector quantity, this is why acceleration is also vector quantity. Okay, so as per the physical quantity, we can we can put it in vector quantity, within vector quantity. And secondly, its unit unit. Let's come to its unit. So since acceleration is what? Velocity or by time, change of velocity means one kind of velocity. So velocity is having unit meter per second, SI unit, and by time, that is second. So meter per or by second into second means second square, that is meter per second square. So we are getting the unit meter per second square for acceleration. This is SI unit. This is what? This is SI unit. For CGS unit, what will happen? It will be centimeter per second square. It is what? It is CGS unit. It is in CGS system. So this is all about acceleration, and we have discussed v equals to u plus at. This is the first equation of motion. Next equation of motions, we will prove this in the next class. Now, next thing I am going to explain, that is uniform and non-uniform motion. Okay, uniform and non-uniform motion. So what is uniform motion? What is non-uniform motion? Let's suppose this is a tree. Let's suppose this is a tree. A path is there. This is a path. This is a cottage. This is another. Achha, this is home. Let's suppose this is home, and this is the destination. This is what? This is the destination. This is the destination. Now, a person is standing here. A person is standing here. Another person is standing here. Another person is standing here. So how many persons are there total now? 4 persons, right? 4 persons are standing where in destination, nearby the tree, near the cottage, and at the home. Now one person or a boy, let's suppose a boy is riding a bike. Okay, he has just got the permission to ride the bike from his father, but his father's instruction is what? That don't ride the bike with very much speed. Go means with slow speed, then you can get the access to ride the bike once again. Okay, this is the condition for him. So to check that how he or she is riding the bike, his father what he has done, he has actually put these persons to see that he is riding okay or not. Okay, so basically he started his journey, but he don't know that this kind of persons are set up here. Right, he don't know. Now here he is going with 30 km/h. Very good. Then here it is going 60 km/h. Now his speed is increasing because he is getting confidence on his riding. Here it is 80 km/h. His speed is increasing continuously. Now here to reach the home, because here his father is standing, so he again is going to the normal speed 30 km/h or 20 km/h. So his father is thinking it's okay, but his father is too much clever. He already set up the persons there. Now he is getting the information. He is collecting the information from these persons that is it okay or something is wrong in between the path. Now these persons means A, B, C, D. A is saying that it's okay boss, he is going with 30 km/h, it is normal speed, no problem. B is saying no boss, it is not like that, he is riding with 60 km/h. C is saying no, he is going with 80 km/h, very much speed, it will be dangerous for him. So if his father got informed about these things. Now B is saying something, C is saying something, A is saying something, and D is saying is saying something. So different speeds, actually we can see that different speeds are there, right, at different places. means his speed is not constant. If constantly he moves with 30 km per hour to 35 km per hour, then it is constant, almost constant. But it is not like this. So when this kind of things is happening, means velocity or speed is not constant, not fixed, then this kind of motion is known as non-uniform motion. Okay, means when velocity or speed is changing point to point, it is non-uniform motion. If it is fixed, means here it is 30, here also it is 30, here also it is 30, here also it is 30, then obviously it is uniform motion. But this is how you can I can explain and you can understand the things, but how you will write the things in your exam, right? You have to write down now. So what is the methodology? See, for that, for simplicity of this one, we are taking a path and we are dividing this path like this into 3 equal segment. I am dividing, like this one is 30 km, this one is also 30 km. I am not saying 30 km per hour, this is just distance. I am saying 30 km, 30 km, 30 km, 3 equal distances. Now his bike is moving along this path, and it for this path, since equal distance, for this path it is taking, let's suppose 1 hour. Let's suppose it is taking 1 hour. For this one also it is 1 hour. For this one it is also 1 hour. Means you can see that 30 kilometer for traveling 30 kilometer it is taking 1 hour. Similarly for next 30 it is 1 hour. For next 30 it is also 1 hour. Means over the distance or over the time, the speed is constant speed. If let us suppose here for this path he is riding the bike with more speed, right? More speed means what? His time will be less for that condition, but time is equal. 1 hour, 1 hour, 1 hour means what? Means the speed is constant, 30 km per hour in each case, 30 km per hour in each case. So it is known as uniform motion. So equal distance traveled by equal time interval. These are equal distances. Equal distances traveled by equal interval of time. Equal interval of time. Intervals of time. What is this? Uniform motion. So uniform motion is what? Equal distances traveled by equal interval of times. Okay, intervals of time. Now if it happens that time is fixed, let's suppose time is fixed, means I am giving 10 minute times. Okay, 10 minutes and 10 minutes time. For the first case it is moving 10 km. For the second case it is moving like 20 km. For the third case it is moving 5 or 25. Let's suppose 25 km. Okay, so in first 10 meter it is moving how much? First 10 minutes it is moving 10 km. Second 10 minutes if it moves 10 kilometers, then these two are same and we can say that their speeds are equal for both the cases, and for that situation I can easily say that the motion is uniform. But since for first 10 minutes it is 10 kilometer, for second 10 minutes it is 20, for third 10 minutes it is 25, so here what is happening? Here speed is changing. Speed is changing means unequal distances are traveled by the equal interval of time, right? These are not equal. Unequal distances are there. So unequal distances traveled by equal intervals of time. This is known as non-uniform motion. Okay, or even you can say equal distances traveled by unequal interval of times. That is also the definition of non-uniform motion. Now, one concept comes basically from the concept of non-uniform motion, that is known as average velocity and average speed. Average speed and average velocity. Okay, so this concept comes actually average speed and average velocity. What is this actually when it comes? So basically, for this case, if I take the same example, for this case it is 30 kilometer per hour, it is 60, it is 80, it is 30. So there are a lot of time in lot of instance of time when I am getting different speeds. So to get the equal speed, or to get the average of them, we will not do direct average. Like, we know how to make average, right? Like there are three persons having weight 46 kg, 47 kg, 48 kg. Then what is the ratio of these three? So we what is the mean of these three ages? So we add up all these three terms and divide by 3, then we get the average. But here it will not happen like this. Means if you add up these terms, 30 kilometer per hour, 60 kilometer per hour, 80 plus 30, then divide by 4, it is not the answer. Okay, so what is the method, what is the formula for this one? You have to add the distance, total distance you have to calculate, and the calculate total time taken to cover the distance. Okay, means for the path, let us suppose this is the path, and it is 40 kilometer and it is 50 kilometer. Let us suppose it is 50 kilometer. It is taking 1 hour to travel, it is taking 2 hours to travel. So how you can find average speed? For average speed, let's consider that motion is uniform motion, and motion is one directional motion. Now 40 and 50, this is total distance. Total distance is how much? That is 40 plus 50 means 90 kilometer. And total time is how much? Total time is how much? That is 1 hour and 2 hours, so 3 hours. Means 1 plus 2, how much we are getting? 3 hours. So 90 by 3 means how much? That is 30 kilometer per hours. 30 kilometer per hours. This is what? This is total distance by time. This is known as average speed. So average speed is what? Total distance by total time. Total distance is 90 kilometer. Total time is 3 hours. If you divide this, you will get 30 kilometer per hour. Okay. So this is how speed can be calculated. Similarly, for average velocity, what is the formula? For average velocity, formula is displacement by total time. Displacement by total time. Displacement by total time. Now let's come to some problem on average speed and average velocity, right? Let's come to some problem. Now we have to find out the average velocity basically for this journey. Here it is 40 kilometer per hour. Here it is 60 kilometer per hour. The distance means this is, let's consider that this one is the time, means for this path from A to B. From A to B, it is moving with means it is taking the time, let's suppose 2 hours. And for this one it is taking 3 hours. I am just taking arbitrary values. Okay, I am taking just arbitrary values. Now 40 kilometer per hour is that speed which is fixed over this path. 60 kilometer per hour is fixed over this path, means this path is traveling constantly with 60 kilometer per hour. This path is traveling constantly with 40 kilometer per hour. For this path it is taking 2 hours. For this path it is taking 3 hours. Since velocities or speeds are different for these two different paths, this is why we need to calculate the average speed. How we can calculate? So what is the formula for average speed? V average is equals to total distance divided by total time. This is the formula, total distance by total time. Total time. Now total distance is how you can calculate. See, this is the speed, this is the time. So speed into time means in this kilometer per hour means in 1 hour it can go 40 kilometer. In 2 hours, how many distance you can go? 80 kilometers. So 80 kilometer is the distance from A to B. This is 80 kilometer from A to B. Now for 1 hour it is taking 60 kilometers. So in 3 hours, how much path it will go? 180. So 180 kilometer it can go from B to C. So what is the total distance? Total distance means 80 kilometer and 180. So 80 kilometer and 180 kilometer. What is total time? Total time means this 2 hours and 3 hours. So 2 plus 3 hours. 180 plus 80, how much? 180 plus 80 is how much? That is 260 kilometer divided by 5. If you cancel this term, then you will get the actual answer, which is 52 kilometer per hour. So this is how you can easily calculate the value of average speed or average velocity. You need to find out the total distance for this case. Okay, means like here total distance was not known. So for this case we need to find out at first the total distance, then divide by total time. If these two values are given, that this is 40, this is 60, what is average speed, then you add up 40 plus 60 by 2 and you are getting 50. It is very much wrong. It is not the way to do the average. Always try to remember the formula for average speed, which is total distance by total time. This is only one formula for average speed, no other formula. Okay, means you need to find out the total distance and total time for getting the average speed. Okay, so I think this video is helpful for you. So today in this lecture I have discussed about acceleration, positive. I have said about positive and negative acceleration, I think. Oh no. One thing I have forgotten actually. The thing is acceleration may be of two types. Okay, one is positive acceleration, means when velocity is increasing. When velocity is increasing, that is positive acceleration, means final velocity is greater than initial velocity, right? See, means if a car is in this place is moving 20 meter per second and after some time its speed is 30 meter per second. So this is final velocity 30 and this is initial velocity 20. So what is the difference? Final minus initial. Final minus initial means 30 minus 20, it is positive 10 it is getting, na? So then the value is positive for this case when velocity is increasing. When velocity is decreasing, then what will happen? Then final velocity will be less than initial velocity, means v less than u, right? When v less than u means final velocity less than initial velocity. So finally velocity is decreasing. Finally velocity is decreasing means deceleration or retardation is happening. Okay, when it is negative acceleration means a is negative. When a is negative, then this kind of acceleration is known as retardation. Retardation or negative acceleration or deceleration. Or what? Or deceleration. So acceleration may be of two types, positive, negative. I will discuss in further more details in the next class, because next class is going to be on graphical representation of the of motion, means all distance, displacement, speed, velocity, acceleration, all the things will come in a gist way there, and you will get the idea of all the formulas or laws of motions. Okay, so I think the next video will be very much informative. So continue watching from the beginning part, from part 1. If you are watching my video, then motion will be clear for you. Class 9 motion chapter is one of the most vital chapter, and a lot of questions are asked from this chapter. Okay, this is means larger than the other chapters. A lot of concepts are here, and also problems, NCERT problems I will going to discuss after completion of this chapter. So try to stay connected with me. And if you have any doubt, then you can comment on the comment section. If you need any videos or any lecture regarding this, any problem solutions, then you can mention all the things in the comment section. I will try to work on that comment. Okay, so I hope the video is helpful for you. If it is, you can hit the like button and subscribe this channel if you are new to this channel. Okay, thank you very much.